Hey guys, what's up? Welcome to the stream. Hope you are all having a fantastic Monday. Hopefully everything's going swell and all of that. What I'm going to do today is I'm going to be telling you about space. The caption or the heading of this is Encyclopedia Space. So, without further ado, shall we get it rolling? First one, let's go. So the first one we're going to do, it's called the Sun's family. The solar system. Okay, first I'm going to read like the main, like this. I'll read this part and then like maybe tomorrow I'll continue with the rest depending on where we finish or end stream. So first it says, the solar system is a vast disk of material over 30 billion kilometers, 19 billion miles across, with the sun in its center. Most of it is empty space, but scattered throughout are countless solid objects bound to the sun by gravity and orbiting, traveling around it, mostly in the same direction. The biggest objects are almost perfectly round and are called planets. There are 8 of them, ranging from the small rocky planet Mercury to the gigantic rocky planet Mercury to the gigantic Jupiter. The solar system also has hundreds of moons and dwarf planets, millions of asteroids, and possibly millions or billions of comets. Millions and billions of comets. So that's the first page. This is what it looks like. Moving on. Around the Sun, Chapter 2. Trapped by the Sun's gravity, the 8 planets of the solar system travel around the central star on nearly circular paths, spinning like tops as they go around. Can anybody tell me? Can anybody, like literally anybody at all, tell me what spinning around is? What is another name for spinning around? Especially, we use it especially in astronomy. 5, 4, 3, 2, 1. Done. Orbiting. That is what it's called. Right. The farther a planet is from the sun, the longer it takes to orbit and the slower it travels. The furthest planet, Neptune, takes 165 years to get around the sun and moves at just over 3 miles per second. So that is actually quite fast, but we don't realize it. Earth, meanwhile, bowls through space nearly 6 times as fast, and Mercury, the planet nearest the Sun, whizzes around it in just 88 days at a speedy 50 kilometers, 30 miles per hour. So you can imagine how fast that is. Guys, instead of doing it there, I'm going to be doing it here. Don't worry if you're missing out on something. I'll go back and read it. Sorry guys, I'm just busy here with the cabling and all of that. Right. I think I should aim it this down, guys. So you can see, like, as I read, you can see where I am. So, next we're still on the same topic. Don't you guys worry. Don't you worry. Anyway, next. I said in 88 days. The planet's orbits are not circular. Instead, they follow a slightly oval path known as ellipses that take them closer to the Sun at one point. Mercury's orbit is the most elliptical. Its farthest point from the Sun is more than 50% farther than its nearest point. So you can imagine, here's the Sun, right? Wait. Here's the Sun, right? Then here's Mercury going around it like this, and around it again, and around it. So you can imagine how far that is, hey? Okay, guys, I'll just be right back now.
You not need to make some No.
Sorry, guys, I was just getting my phone. We can carry on now. Having some more fun with space. Next page. Birth of the solar system. Screw it, I'm using your phone.
No.
Just keep my phone. Just keep that.
Ooh. Well done breaking the task to
Good job. Carry on. Right. I'm just going to move it up so I can see. Don't you guys worry. Birth of the solar system. The planets of the solar system formed from gas and grains of dust and ice surrounding the newly formed sun. The solar system was born inside a vast dark cloud of gas and dust. About 5 million years ago, something triggered a burst of star formation in the cloud. Perhaps a nearby star exploded, sending a shock wave rippling through the cloud. Hundreds of pockets of gas were squeezed into clumps. Their gravity pulled in more and more gas, making the clumps larger and denser. This made them heat up inside and start to glow. Eventually, the cores of the clumps got so hot and dense that nuclear reactions began and they became stars. One of those stars was our sun. I'll get to the trivia time just now. No, I think this is the next page. Yeah. After this chapter, I'm going to quiz you, eh? So leave some space for your vast knowledge today. It's Monday. I have to keep you guys up and running, up and running, up and running. Right, boys. The sun. Our sun is a typical star, a vast glowing ball made mostly of super hot hydrogen and helium gas. The sun has been shining for nearly 5 billion years and will probably continue to shine for another 5 billion. More than 1,000,000 times larger in volume than Earth, it contains over 99% of the solar system's mass. The tremendous force of gravity generated by this mass keeps the planets of the solar system trapped in orbit around it. The sun's source of power lies buried deep in its core, where temperatures soar to 15 million degrees Celsius, 27 million degrees Fahrenheit. The intense heat and pressure in the core trigger nuclear fusion and let me just restart that sentence. The intense heat and pressure in the core trigger nuclear fusion reactions, turning 4 million tons of matter into pure energy every second. This energy spreads upwards and to the seething surface of the sun, where it floods out into space as light and other forms of radiation. So now this is the point. This is the point where we start learning about like the different types. So just keep that in mind as we are going along here. Sorry guys, I'm just trying to get this straight. I have nobody watching. Who am I kidding? Right. So this is the point where we start learning about all the different planets. And don't worry, I will read you the facts on the bottom half of the page. Okay, 5 facts of the sun. Diameter is 1,392,684 kilometers, 865,374 miles. So if you're ever interested in astronomy, just come to like Benoni. Mass or Earth equals 1. It takes 333,000 of Earths to fill out the mass. And I don't know if you guys can see this, but this little dot right here, that is one of our Earths. So you can imagine the size difference, eh? Anyway, surface temperature is 5,500 degrees Celsius, 9,930 degrees Fahrenheit. Core temperature degrees Fahrenheit. Okay, we can move on. Now we get the next system, Mercury. So, Mercury, fun facts. Okay, here we are. Here we go. So, I'm just going to turn this off because you guys can see pretty well. Okay. Mercury. The planet Mercury is a giant ball of iron covered in a shallow layer of water. It is the smallest planet and the one closest to the Sun. Mercury is the speedster of the planets, completing its journey around the Sun in just 88 Earth days. So picture this, okay? So picture this. Mercury starting its orbit today will end in about 4 months. 4 months from now. At the brisk pace of 1,000 kilometers per hour. And that is 108,000 miles per hour, which is faster than any other planet. Scorched by the sun's heat, Mercury's dusty moon-like surface is hotter than an oven by day, but freezing at night. Once struck with such violence that most of its rocky outer layers were blasted away into space. So, it's lighter, way lighter than Earth. Earth days. Year is 88 Earth days. Moons, it's got none. We have Venus. That's flight track, man. Not that top. Venus, our nearest neighbor in space. Venus is very similar to Earth in size. However, the furnace-like surface of its rocky planet bears little resemblance to our world. Venus is cloaked in swirls of yellowish clouds. Unlike Earth's clouds, contain life-giving water. These clouds are made of deadly sulfuric acid. The atmosphere is so thick that pressure on the planet's surface is 92 times that on Earth. Enough to crush a car flat. At 460 degrees Celsius, 860 degrees Fahrenheit, the surface is also hotter than that of any other planet in the solar system. So basically what it's saying now is if you were to live on Venus, you'd only survive about 20 seconds. That's the sad part. surface gravity, Earth equals 1. It's 9, it's 0.09 away. It's 0.91. Moons, it has none. Year is 225 Earth days. Time to rotate once is longer than its year, with 243 days. Live. The planet that we live on. Of all the planets known to science, ours is the only one known to harbor life and to have vast oceans of liquid water on the surface. Earth's distance from the sun and Earth's distance from the sun and its thick atmosphere mean it never gets very hot or very cold at the surface. In fact, it is always just the right temperature for water to stay liquid, making life as we know it possible. That is very different from scorching Venus, where all water boils away, and icy Mars, where any water seems to be frozen. Life on Earth began around 3.8 million years ago. Soon after, the newly formed planet cooled down, allowing water to form oceans. Since then, living organisms have slowly transformed the planet's surface, coloring the land green and adding oxygen to the atmosphere, which makes the air breathable. I got a question for you guys in chat. I got a question for you guys. How, at what angle is the Earth's axis at? At what angle is the Earth's axis at? Question. Five, four, three, two, one. It is at 23.45 degrees. Right. Fast fact time. Time to rotate once. The scientists have lied to us once again, and have said it takes 24 hours to rotate once. Incorrect. It takes 23.97 hours to rotate once, but we're just too lazy. A year on Earth is 365.26 days. Moons, we only have one, the beautiful moon. Average temperature is 16 degrees Celsius and 61 degrees Fahrenheit. I'll be right back. To any of you who are watching whose internet's bad, I apologize. Nudge, nudge, wink, wink. Right. Inside Earth. Actually, guys, I'm going to tilt this up so you can see me read it instead of saying that thing read it. Like that. Inside Earth. If you could pull Earth apart with your hands, you discover it's made up of distinct layers that fit together like the layers of an onion. Earth is made almost entirely of rock and metal. When the young planet was forming and its interior was largely molten, heavy materials like metal sank all the way to the center, while lighter materials such as rock settled on top. Today, Earth's interior is mostly solid, but it is still very hot, with temperatures rising to 6,000 degrees Celsius, which is 10,800 degrees Fahrenheit, in the core, which is hotter than the surface of the sun. This powerful inner heat keeps the planet's interior slowly moving. Whoever can tell me why these are here, I swear, you are an absolute legend. 5, 4, 3, 2, 1. Time's up! It is called tectonic plates. Right. Next page. The moon. The moon. So large and bright that we can see it even in daytime, the moon is the only object in space whose surface features are visible to the naked eye. The moon is a quarter as wide as Earth, making it the largest moon relative to its parent planet in the solar system. It is also the largest and brightest object in the night sky by far, and its fascinating surface, scarred with hundreds of thousands of impact craters, is a spectacular sight through binoculars or telescopes. The moon formed about 4.5 billion years ago, shortly after Earth, but unlike Earth, its surface has hardly changed in billions of years. The dark seas, or maria, on its near side are flat plains formed by giant floods of lava that erupted about 3 billion years ago. Surrounding these are the lunar highlands. They're ancient hills and valleys littered with the debris of countless meteorite impacts. Right, it's time to orbit the Earth. 27.232 Earth days. Mass equals 1, but this is 0.167. Distance from Earth is 385,000 kilometers or 239,227 miles. Average diameter is 3.474 kilometers or 3,474 kilometers or 2,159 miles wide. Right. Alright. Then I'll show you all these like pictures at the end. I'll give you a few minutes to just check them all out. Oh, by the way, if you want to get these books, you can go to, I think, Decorative Kelly or something like that. I know, it's Dorling Kindersley Limited. Huge shout out to them. Thank you. Impact craters. Asteroids, comets, and meteorites fly through space at such terrific speeds that they release devastating energy when they collide with planets and moons, vaporizing solid rock in an instant. The scars they leave behind are called impact craters. Meteorite impacts have scarred the rocky planets and moons with countless craters. Our moon is covered with craters, but Earth has far fewer. On Earth, craters are destroyed by erosion and other forces, while those on the moon remain preserved for billions of years. Many of the moon's craters formed early in the solar system's history, when the inner planets were bombarded by asteroids. Collisions are much more rare today, but they still pose a deadly threat to Earth. Ellipses. Me sometime. Ellipses. A total solar eclipse. Sorry, eclipses. A total solar eclipse is an amazing event. For a few minutes, the sun disappears behind the moon and day turns suddenly to night. Eclipses happen when the Earth and the moon line up with the sun and cast shadows on each other. When the moon casts a shadow on Earth, our view of the sun is blocked, and we see a solar eclipse. When the moon swings behind Earth and passes through Earth's shadow, we see the lunar eclipse. The moon's darkness and turns an unusual reddish color. For those of you who aren't very big with space, that is very cool to see. That is very cool to see. Alright. Obviously, don't look at a solar eclipse, you'll go blind. Please don't. Don't. Next one. Next one. Next one. Next one. Next one is Mars. Earth's second nearest neighbor in space is Mars, a freezing desert world that may have once harbored life. Have you ever thought, how did we get here? How did we get here? You know, you like wonder that every day. You're scared of death. You worry about that. You wonder about how we got here. I mean, we could have come from Mars out of all the places. Mars is half Earth's size and much colder, but its arid surface looks oddly familiar with the rocky plains, rolling hills, and sand dunes much like those on Earth. The dusty ground is tinged brownish red by rust, iron oxide, and makes Mars look reddish from Earth, which is why the ancient Greeks and Romans named the planet after the god of war. Mars may have been warmer and wetter in the past, and there are signs of water that once flowed across its surface, carving out gullies and laying down sedimentary rock. There may even be fossils of alien life from hidden in the ground. Billions of years ago, vast rivers flowed on the Martian surface, carving out giant valleys. That is very interesting to hear. That is very interesting to hear. We may take an ad break. Surface gravity, Earth equal 1. This is 0.38. Time to rotate once, just longer than Earth, 24.6 hours. Year is almost doubled, 687 days, and there's 2 moons. Who can list those 2 moons? I'll give you a hint. The first one starts with a PH, and the second one starts with a D. 5, 4, 3, 2, 1. Time up. Check chat. Right. Moving on. Rally. That. Oh, shit. Um. Hmm. I want to know how to say it. Okay, I don't know how to say it. Anyway, moving on. 5 times as long and almost 4 times as deep as Earth's Grand Canyon, the massive, you can say it in chat, canyon system on Mars is one of the wonders of the solar system. I'll type it in chat. I saved it. Yo. I saved it. Too bright, but anyway. Bellis. Sure, chat. I'm coming. Okay, guys. Let's take a break. I'll be back. Right, guys, I am back. There, it's there in chat. It's there in chat. It's there in chat. Right. Today it stretches a fifth of the way around Mars and resembles a vast slash in the planet's face. Over billions of years, floods have gouged out deeper channels and landslides have destroyed the valley walls, creating an amazingly varied landscape of canyons, cliffs, and dunes. Fun fact for all you people there. Fun fact, fun fact. And then I'll show you the failed missions and all of that. The red planets. I think that's our next subtopic. Yep, that is another one. I'll go get water and I'll come back. Alright, boys and girls and ladies and gentlemen. I have got my juice. Right, the rust-colored landscape of Mars remind us of sandy deserts on Earth, but the temperature here is as cold as Earth's south pole in midwinter. Mars would be deadly to humans without spacesuits, but conditions are ideal for robotic rovers. NASA's car-sized Curiosity rover took this photo of its tracks on the 9th of February 2014, day 538 of its tour of Mars. The desert hills form part of the rim of a 155-kilometer, 96-mile wide crater that Curiosity is searching for signs that Mars may have once been suitable for life. Should we skip asteroids or should we do it? Right. Millions of rocks known as asteroids hurtle around the inner solar system, most of them in a belt between the orbits of Mars and Jupiter. They range in size from pebbles to monsters, hundreds of miles wide. Asteroids are leftovers from the cloud of rubble that gave birth to the planets. Most of the rubble in the inner solar system collected together to become the rocky planet. but the rocks near Jupiter were disturbed by the giant planet's gravity and failed to build up. The asteroid belt is what remains today of that debris. Asteroids follow their own orbit around the Sun, spinning as they go like planets. They are also called minor planets. And the largest asteroid of all, Ceres, is classed as a dwarf planet. Asteroids occasionally collide, forming craters or even smashing into each other. Less often, they crash into moons and planets. And then the page just goes like this all of a sudden. So, yeah. Shooting stars and meteorites. The shooting stars we sometimes see streaking across the night sky are not stars at all, but tiny flecks of space rock. Millions of these rock fragments, called meteoroids, hurtle into Earth's atmosphere every year. So if you're lucky enough tonight, you may even see one or two. Most meteoroids come from the asteroid belt or form comets, but a few are chipped off the moon or Mars by meteorite impact. They are usually no bigger than a grain of sand, but even tiny grains hit the atmosphere so hard and fast at up to 71 kilometers per hour and 44 miles per hour. Per second. They make the air glow brightly as they ram into it, causing the streak of light we call a meteor or shooting star. Most meteoroids burn up entirely in the atmosphere, but a few really big ones survive to crash into the ground as meteorites. It's this way, yeah. People, I've read so much. I've read up to page 43. I think for today, or for now, we should finish up to the end, to here, of stars. And then, yeah, we've still got 44 and it ends at 67. Should I go to that one? Alright, Jupiter, the largest planet of all. Jupiter is more than twice as massive as all the other planets combined. Unlike rocky worlds such as Earth or Mars, Jupiter is a gas giant, a vast spinning globe of gas and liquid with no solid surface. Jupiter is 1,300 times greater in volume than Earth, and the pull of its gravity is so great that it bends the paths of comets and asteroids flying through the solar system. Despite the planet's great size, it spins quickly, giving it a day less than 10 hours long. The rapid rotation makes Jupiter bulge visibly at its equator and whips its colorful clouds into horizontal stripes. The swirling storms and swirling storms. Sorry, guys. The largest storm, the Great Red Spot, is bigger than Earth. Lightning storms flicker through the blackness on Jupiter's night side, and the whole planet is surrounded by belts of lethal radiation that would make a manned mission extremely dangerous. My English today is so good, eh? So good. Surface gravity. Earth is 1. This is 2.36. So it's doubled plus 0.36. Time to rotate once, just less than 10 hours, 9.9 hours. Year is 12 Earth years, though. And Jupiter has at least 67 moons.